Hi, today we'll be doing an introduction to Coulombic attraction. So Coulombic attraction is basically oppositely charged particles attracting each other, like the positively charged nucleus attracting the electrons. So in a Coulombic attraction, the farther away the distance, the less the attractive force. The farther away the electrons are to the neutrons, aka the protons in the nucleus, the less the force of attraction, aka the Coulombic attraction. So as we can see here, if it's 10 nanometers apart, it's 2.3 times 10 to the negative 8th. And as the farther we get, the number decreases. Alright, and here's the visualization. So, as you can see, this one has one layer of shells, and the attraction is the biggest. This one has two layers. No, actually three, but two outside. And you can see that the attraction is smaller. And now this one, having the most layers, has the smallest attraction. Now, on the side I wrote the number of protons. Protons will play a force, protons will play a role in the Coulombic attraction, but not as much as the distance. And now I'm going to talk about the protons, number of protons. So if the distance stays the same, the more protons equal the higher the charge. This has the most protons, and it has the highest force of attraction. And now over here, although this has 19 protons, but due to the great distance, the protons doesn't matter in this case. Always think of distance first, and if the distance is the same, move on to protons. More protons means more force of attraction. And now here's the example. All three of these outer electrons are equal distant away, as you can see over here, 3 shells away. All these are equal distant, and now you're gonna see which one has more protons. This one, sodium, Na has 11 protons. Aluminum has 13 protons, and chlorine has 17. So as you can see, since all of these have the same number of electron shells, that means the pull, okay, and now the pull on the outer electrons will be the greatest in chlorine because it has the most protons, and the distance here is equal, and chlorine has the most protons. So one with the most protons will also be the one with the largest force of attraction if the distance is equal. Now, a distance play a greater role than protons. So always consider distance first and then move on to protons. Now here's another visual. This is some elements, and the top number is the atomic number. Atomic number, atomic symbol, atomic number, atomic symbol, and then this is how many shells it has. Now this is diagram of its shells, and it shows you how far away they are. And then this is atomic radius, ionization energy, which we're going to talk about in another video, and electronegativity, which we'll also talk about in another video. Now if you take a look, so let's say this row, these elements all have the equal number of shells, which means there's the equal number of shells, which means the more protons, the stronger the attractive force, and the smaller the radius. So over here it has 11 protons. That means the pull is not very strong. But over here there's 18 protons. That means the pull is very strong, which is why the circle is so small. They have the same shells, but the circle is very small. And now as you go over here, look this way. So we have Li, Na, and K. Now notice how in increasing shell means the less the force, which is why they're so much bigger. Li, Na, and K. Alright. Na has a whole extra layer than Li, which is why the Coulombic attraction will be much smaller due to the extra layer of electrons. And now we're going to talk about this in depth and tell you the reason why this occurs in the next video. Thank you for watching.